23, Ionic Equilibria. And in this chapter alone, so there's a few elements that you guys need to pay more attention to, especially on pH calculation. You have to know how to calculate pH of strong acid, strong base, weak acid, and also pH of a buffer solution. After that, it's going to be partition coefficient and also solubility product. So these four elements is very important. These are the key four elements in this chapter. So please pay more attention to it, especially like dealing with questions with long calculation. So please go through the entire notes and go through more questions with calculation. So let's go. Yes! My internet account working against me, bro. Alright guys, now let's go. Okay, how do we calculate the Ka for a weak acid? What do we need, right? We just need the concentration of the weak acid. At the same time, we need the pH of weak acid. Okay, and guys, let's look at the general formula, general equation of a weak acid dissociation. So the general equation, right, it's always HA. Okay, when it dissociates, then it turns into H plus and A minus. Okay, and guys, when just imagine, right, let's say if 0. For example, if I have 1 mole of HA and 0.05 mole of H plus is produced, A minus is also a 0.05. Okay, reason being, right, your H plus and A minus is always in a 1-to-1 ratio, correct? So I can say that HA ionized to form a H plus, what? Too small. H plus and an A minus, Okay, and guys, we know that, right, the concentration of H plus and A minus produced are the same, right? So which means, let's say this is 0.5, right? A minus is also 0.5, it's always the same ratio 1-to-1, right? Okay, next, you can put it down into this Ka equation. So Ka, I can write it as H plus A minus over HA, correct? Okay, so since I know that H plus and A minus are the same concentration, I can also rewrite it as Ka equals to a H plus. Oh, why my notability is lagging a second? Okay, a H plus over a HA, right? Correct. Okay, I can also write it as Ka equals to H plus square over HA. Okay, you can highlight this entire formula. And guys, this is only, you can only apply this equation, right? Okay, only valid for a weak acid. If it's a strong acid, sorry, we don't use this formula. If it's a weak acid, yes, we can use this formula, Okay. Okay, guys, now let's continue. So to apply this equation, right, K equals to H plus square over HA, right? Okay, so we actually made two assumptions here. So the first assumption, right, just imagine that. Okay, at first, right, I have H2O. And I'm adding my HA in, right? So guys, when you add H2 into the solution, right, H2 would dissociate into a H plus and OH minus, am I right? So technically saying, right, H plus, some of the H plus ion, right, comes from H2O also, but we can't tell how much H2O would dissociate when you add a weak acid. Okay, and we know that, right, water dissociation is actually very, very, very small. So first, the first assumption, right, is that we ignore any of the H plus produced by H2O. Okay, highlight this word. We ignore the concentration of H plus produced by water dissociation. That's it. Okay, next. The ionization of weak acid next is the ionization of weak acid right now. So if I add a weak acid right now, right, you see HA, oh bruh. Okay, when I add HA in, right, so it turns into a H plus and A minus, right? So guys, what we assume here, right, is the initial HA and the HA after dissociation, right, the concentration stays almost the same. Okay, so that's the second assumption that we made. So the ionization, highlight this word, ionization of weak acid is so small so that the concentration of undissociated HA, okay, is the same as, okay, that of the concentration of weak acid after dissociation. Okay, highlight concentration of undissociated HA, same as concentration of weak acid after dissociation. Done. Okay, guys, please write it down. When it's done, let me show you one example. Yeah. Okay, now, first example, calculate the Ka of ethanol. Oh my God, are you methanol acid with a concentration of 0.01 pH 2.9. Okay, first what you need to do, right? Please convert your pH into a concentration of H plus. Yeah. So I do know that the formula of pH plus, right, is 10 to the power of negative pH. So plug it in is just 10 to the power of negative 2.9, right? That's it. So guys, that's the first step. Yeah. Hey, where's my phone? Please write it down. Let me mark my attendance. Attendance not marked yet. All right, guys, next. The second step, right, is to write down your equilibrium expression. So guys, how do you write your equilibrium expression, right? Okay, you can write a weak acid dissociation equation. When they dissociate, right, it turns into a HCOO minus and a H plus, am I right? Okay, so I can write a Ka as a H plus, HCOO minus over the undissociated acid. Is that right? Okay, and guys, I do know that, right? HCOO minus and H plus are the same, correct? So this entire equation can also be written as a H plus square over HCOOH, correct? Okay, finally, enter the value, calculate Ka. Let's go. Oh my God, my phone can't recognize my face. What the hell, man? Bruh. Yeah, it's my glasses, bro. Legit, Apple ID failed to recognize my face. What on earth, bro? What is this nonsense? Oh my God, are you serious? I cannot mark attendance. Okay, bruh, my glasses. Huh? Okay, let me mark attendance. Okay, guys, now Ka calculation, go. H plus is 10 to the power of negative 2.9, right? Bruh. And the concentration 0.01, right? Press the calculator now. Let's go. Wait, let me record. Let me see. Let me check the attendance. See who skipped my class. Kai Hao skipped my class again. That fella. Yun is here. Chloe is not here. Ethan is here. Jonas and Ding Xiang is not here. Kun is here. Lin is here. Rong not here. Lukash, Marcus. Okay. And Victor. Guys, one's done. Please let me know your answer. It should be 1.58 times 10 to the power negative 4, right? Correct. Yes, sir. Okay, one's done. Next page. Sorry, not next page. Bottom question. Let's go. Victor. Where did the square go? Hey, yeah, my bad. I missed out a square. That's a square. The square is still there. Takina, Jasper, All right, come first question. Let's do it now. All right, come. Calculate the Ka of methanol acid at 25 degree 0.1. B, you help me answer my call, my sister. Oh, yeah. Oh my God. Connected to my iPod. You change it back. Okay, so calculate the value of Ka if the concentration is 0.1 and your H plus ion, yeah, it's 4.13 times 10 to the power negative 3. Okay, so again, right, guys, the first step, please identify your methanol acid. It's just HCOH, right? Now. Maybe we go later after my class. Then I just eat a bit. Later. HCOO minus plus H plus, right? Then, guys, Ka equation. Plug in the value, get me the answer. I think the first one is pretty easy, right? H plus square, HCOOH. Your answer is just gonna be 4.13 times 10 to the power negative 3 square divided by 0.1, right? Answer? 1.71. Oh my god, my point. 1.71 times 10 to the power negative 4. Is that right? Try the second question, guys. Same thing. I need Ka value. Let's go. Ka value of HCM. I would say it's the same question, right? Please share your answer, yeah, guys. I'll get you the answer. 3.98 times 10 to the power of negative 10. These two questions is pretty straightforward, yeah. Please check. I hope you guys get it right. Wait, 还好 30 minutes later. What on earth? Where do you go? Class started 6:30. Just woke up. Well, ask Areta to give you a morning call next time, right? You guys done, yeah? I think question 2, you guys don't need me to show you the working, right? Okay, guys, let's skip it. Now let's look at the pH of a weak acid. Sending you the video. Okay, now, okay, to calculate the pH of a weak acid, right, what do we need to know? We need to know the concentration of the weak acid first. Right. Okay, the second one, right, the Ka of the weak acid. So the first one is the concentration. The second one is the Ka of the acid. Okay, so the same assumption that we have made before, the concentration of H plus ion, okay, produced by the water is negligible, yeah. And next, the second one, right, is the undissociated concentration of HA. It's the same as dissociated concentration of HA. Yeah? No worries, 小事。 Yes, what's up? All right, guys, I'm back. So again, so first calculate the pH of 0.1 mole per dm cube of ethanoic acid, and I have the Ka equation, yeah. So first step, right? Kid, can you write down the Ka equation? Go, 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 write down the Ka first. Follow the step. Write down the Ka. Correct. Yeah, very bright. And guys, after getting this, I know that H plus concentration of your anion concentration are the same, right? So I can say that this entire equation can be written as a H plus square CH3COOH, right? Go, go. And after that, guys, we arrange the equation. Go. So, guys, move this entire thing over. And I say that H plus square equals to Ka times the concentration of CH3COH. And after that, square root it. Right. And the final step, put in the value, calculate pKa, right? Put in the value, calculate pH, right? Square root of my K equation is 1.74 times 10 to the power of -5, right? And concentration of your acid is just 0.1, right? Correct. Finally, negative log base 10, concentration of H plus. I would say this is just, how much is it? Press your calculator, you should get 2.88. Is that right? Done. All good, guys. Okay, now let's continue. Hit. Now I'm going to give you a study tips. Let's say to calculate pH of weak acid quickly, right? You can use this hack. Sorry. Okay, so pH of weak acid, right, guys? The equation is just square root of Ka multiplied by the concentration of the acid. Done. Okay. Hey guys, try this question. Go.
I think I'm forgetting a log.
Sorry. Ah, ah. You see, right? This is what happens when I get distracted. Yeah, I'm forgetting a lot. Thank you so much for reminding. Yes, yes, yes. Sorry, sorry, my dear. Never this doctor is tired now. Thanks, Hao Jie. Okay, guys, question. Let's go. Okay, give me the answer, guys. Before we move on, pH of weak acid, and right. Next part is gonna kill you guys. pH of buffer. What's your answer, guys? The second one. Okay, so my pH is negative log base 10 square root of 4.8 times 10 to the power of negative 11 multiplied by 0.3, right? So if my answer is right, I have no calculator now, 5.42. Is that right? All right, yeah, 5.42. Well done. Once done, okay, let's move on to next page. Guys, what we're gonna do, right, is to try out some question, yeah, before we move on to buffer solution. All right, so we're just gonna do a few questions because buffer solution, trust me, guys, the hardest question that you will encounter, right, in this chapter is buffer solution. Yeah, buffer is the hardest one. So weak acid strong. So now let's see, guys, what we have done so far. We know how to calculate the pH of a strong acid. You guys know how to calculate, right? pH of a weak acid using this formula. Okay. Next, pH of a strong base. And pH of a weak base is not in the syllabus. So there's no need for you to know how to calculate a pH of a weak base. It's not in the syllabus. So do re mi. That's what we have done so far. And also forgot my Ka and pKa. That's it. Now what I want you guys to do, let's go. Guys, try this out now. Q is commonly used in conjunction with aspirin. Aspirin is a weak prostacyclinic acid. And guys, they say pKa of aspirin is 3.49 and 75 milligram of aspirin, okay, dissolved to form this amount and calculate the pH. So kid, again, if you have no clue, right, like no clue at all, guys, just follow my step here, okay? Just follow the step, guys. Try to follow the step. Okay, try to follow the step or follow this equation. You should be able to do it. Go, go, go. Try. Okay. I'll give you guys 2 minutes. Yeah. Please try first because this question is not too bad. But 3 marks for a not too bad question. Lucky you guys. Wah, cepatnya. Okay. Okay, guys, I have answer coming in. 2.94. Okay. I'll discuss once I have 3 answers from you guys. 3. Okay. Thank you. 2.94 times 2. Thank you, Adrian. Thank you, Colleen. 2.9. You. Nice one. Thank you, Ethan. Yeah, I mean, tried it, guys. Tried it. I'm happy. Okay, so guys, I'll slowly guide you guys how to do it. Yeah. So pH equals to negative log base 10, concentration of Ka times the weak acid concentration, right? So Ka not given. Concentration, both not given. So first step, perhaps you can find out what Ka is, right? Second step, concentration of the Ha. Third step, pH. 3 step, done. So guys, how to find Ka? Equals to 10 to the power of negative pKa, right? So I can put it as 10 to the power of negative 3.49. First step done. Second step, Ha concentration. Guys, it's milligram. Milli is times 10 to the power of negative 3, right? Divide by, this is how much? 0.1 dm cube, right? So you get 75 times 10 to the power negative 2 gram per dm cube. And guys, you have to find the concentration in mole per dm cube, right? Please divide by mr. GG. Never mind, let me get my calculator. Hiya. Where's my bag? Bag. Yeah. Oh, it's underneath the table. Yeah. Okay. It's gonna be 0.417, right? Hey, So guys, now I get the concentration, I get the Ka, finally pH, right? Negative log base 10, Ka, Ha. 2.3935, right? More than. Okay, not too high, right? All right, guys, please try your answer, yeah. 3 step, done. Next page. Hey, sorry, next question, kid. We're just gonna do one of two more questions before we move on to buffer, yeah. Buffer is the hardest. Like, buffer is super difficult. Yeah. I mean, it's doable, not to scare you guys. It's actually doable. If you follow the hack, follow the step, it's doable. Yeah, but a bit tricky. Okay, guys, now let's go. Is the shortcut working accepted? Of course. Of course. As in this method, is it? Yeah, it's accepted. Wow, so fast. Well, thank you so much. Very quick. Okay, 1.83, right? Thank you very much. All right, guys, a second. Let me check on this question. I want to see the mark scheme where they award their mark. So you guys know how to write your working. I just want to see how they award the mark first. Give me a quick minute here. You guys do the next question first. Question 5. Okay, 1 mark for the concentration of HA. Another mark for pH equals to negative log base 10. And last part for, you have to write down the equation. Equation carry 1 mark. Oh my God. Yeah. So the equation, basically this has no mark, stat. So basically 1 mark for the equation, 1 mark for pH calculation, 1 mark for concentration of HA. Okay, thanks, Hao-Jie. Yeah. Okay, guys, next. Acidic due to the equation pH of a 0.25 of FeCl3, right? FeCl3 is here, yeah. Okay, so guys, show you working. I can say that Ka is equals to okay, you can just write it as a H plus A minus. Oh my God, so annoying. HA. So eventually I can just say that H plus equals to a square root of Ka times HA, right? pH, negative log base 10. How much? Okay, I can see the mark again. 1 mark for the equation. Then 1 mark for the pH, 1 mark for the concentration of HA. That's it. Welcome. This is 1.83, right? Good job, guys. Doable? Your weak acid, okay, calculation of weak acid is that simple, guys. It's not that hard, follow through, We're gonna go step part by part, So I get you guys a lot of questions to copy, to practice. Do you guys want to do this? Kid, do you guys want me to try 3 or you guys want me to move on to buffer? Wood now, let's go. This is a 4 marks question. Hey, sorry, this cannot. My bad, it's a pH or buffer. Hello, skip. Okay, then I think the other question you guys should be able to do it. Okay, you guys do it yourself, yeah? Right now, let's move on to buffer. Page 15, buffer solution. Ooh, yo. Guys, I will go very, very, very slowly for buffer, yeah? Reason being buffer is one of the toughest calculation, okay? So guys, now, first, okay, the very popular question that you might encounter in exam, right, is define buffer solution. So guys, buffer solution stand for a solution that resists the change in pH. When a small amount of acid or alkaline is added. Okay, so resist a change in pH, right? Small amount. Keyword, resist a change in pH. Keyword, small amount acid alkaline added. That's it. Alright, guys, you see, we have two different type of buffer solution. Okay, in exam, right? In your in A levels, you guys only be dealing with acidic buffer, yeah. So how do you get acidic buffer, right? It's you get a weak acid and its conjugate salt. Take a weak acid, add a conjugate salt, then that's your acidic buffer. Alkaline buffer, take a weak base and a conjugate salt. Done. Alright, guys, remember that acid always forms a conjugate base. Okay, and base always form conjugate acid, right? Done. Okay, all good. Alright, guys, if all good, let's look at acidic buffer solution, yeah. So, guys, what is acidic buffer, right? You must take a weak acid, remember, yeah? We take a weak acid and its salt. Okay, highlight the word weak acid and its salt. So example, guys, you see a weak acid and a salt. Okay, and its conjugate salt. So let's look at the weak acid first. So weak acid always dissociate partially, am I right? So it dissociate partially. Okay, only give rise to a low concentration of H plus ion. Okay, so remember, yeah, weak acid dissociate partially. Example, right? I have ethanoic acid, and when they dissociate, just partially, CH3COO minus and a H plus. All good. And guys, what about the salt? So guys, let's look at the salt, which is a CH3COOH, right? Okay, so your sodium ethanoate. Okay, and salt, right, dissociate completely. Okay, it's fully dissociated in aqueous solution. Okay, highlight this, write it down. Salt always dissociate fully in aqueous solution. Okay. And guys, next, let's write down the equation. I'll write the equation. It's gonna be a CH3COO and A turns into a CH3COO minus and Na plus. Done. Okay, so guys, again, yeah, in order for you to have a buffer solution, you must have a weak acid and its salt. So guys, let me draw it out so you can visualize it. So this is how we make a buffer, yeah. So at first, right, guys, you see, I add in a CH3COOH, correct? So when I add in, so in the solution, right, you have a lot of CH3COOH, correct? So you have a lot of CH3COOH, understand? Okay, then at the same time, I'm gonna add in its salt. And when the salt is added into the solution, it dissociates fully. So you have high amount of COO minus. So your COO minus concentration, right, is also very, very high. Understand? Okay, please draw it out. So at least you know, always remember in buffer solution, your acid and its conjugate are always in a very high concentration. Okay. So guys, the buffer solution contains relatively high amount of the acid, okay, CH3COH and its conjugate salt, yeah, or its conjugate base. So if this highlight the word high amount of acid and its conjugate. So if this concentration do not change much, the pH will remain the same. Okay, highlight. This concentration do not change much, pH remain the same. And guys, nice. Let's look at the equation here. So guys, you see, right, this equation is the same as a weak acid dissociation equation, right? Can you see that they are the same? So this equation, right, we also call it as a buffer equation. As for buffer equation, right, it's the same as a weak acid dissociation equation. They are the same thing. Okay. Please don't post that. We need to just did my makeup so now it's done. Okay, now guys, let's say, okay, what happened when acid is added into a buffer solution? Guys, you see, right? So when you add an acid, concentration of H plus in the solution increases. So H plus, the additional H plus, right, is being removed by CH3COO minus, forming CH3COH. So the H plus eventually returns to original. And the pH will stay. One more time, when acid is added, initially H plus increases. It's going to combine with CH3COO minus, forming CH3COH. Okay, then at the end of the day, H plus returns to its original concentration and the pH did not change. Okay, now, so the H plus ion added will shift the position of equilibrium to the left, right? Why? Because the H plus ion will combine with the CH3COO minus to form a CH3COH. Okay, and guys, next, the large reserve of your acid, CH3COO minus, and your CH3COOH, ensure that the concentration of H plus, right, does not change significantly. Highlight the word large reserve of CH3COO minus and COOH, the concentration of acid and its conjugate, it's at a very high concentration, which means the concentration of H plus will not change. Okay, please write it down. Okay, therefore, your pH doesn't change significantly. Done. Oh, good. Okay, now, guys, what happens when OH minus is added? So if you're adding OH minus, right, you see alkaline is OH minus. So when you add OH minus, right, this OH minus will consume with H plus, right, forming H2O. Okay, so OH minus, right, once again, will react with the H plus available in the solution, forming a H2O, yeah. Okay, so an increase in OH minus will combine with H plus ion, forming H2O, right? Okay, then what happens? Reduces the concentration of H plus. So guys, you see, right now, the concentration of H plus decreases. So what this equation gonna do, right? Ethanoic acid is gonna dissociate more to form CH3COOH and H plus. So eventually the H plus concentration returns normal. Okay, which means the concentration of H plus, which means the pH, okay, does not change or remains the same. Understand? So I can say that the equilibrium shift to the right, CH3COOH ionize to form more H plus ion and CH3COO minus ion. Okay, and the large reserve of CH3COOH and CH3COO minus ensure that the concentration of H plus does not change significantly. Done. Understand? Okay, guys, please write everything down. We are moving on to alkaline buffer solution. Okay, guys, let's look at alkaline buffer solution. The same thing. What do you need, right? We need a weak base. And its conjugate. So NH3 is a weak base. And a conjugate CH3Cl8. And the conjugate, which is ammonium chloride NH4Cl. Yeah. Okay, next. NH3 is a weak base, so there's only a low concentration of ammonium ion. Yeah. Okay, let's look at NH3. So the same thing, guys, you see, originally, I have a solution here. I add NH3, boom. So when you add NH3, right, the concentration of NH3 originally is very high. Okay, so NH3 plus H2O turns into an NH4 plus and OH minus, right? Okay, next. At the same time, we are adding another conjugate salt, which is NH4Cl. So we add NH4Cl, right? Concentration of NH4 plus is also very high. Okay, why? Because ammonium chloride, right? It's a salt, and salt always dissociate fully. So you get a NH4 plus and Cl minus. Done. Please write it down. And guys, now we have the buffer equation. Remember, yeah, guys, buffer equation, right? It's always the same as a weak acid dissociation equation. Okay, remember, buffer equation is always the same as weak acid dissociation equation. And always remember, acid, it's a proton donor, correct? So let's look at your ions. Which one is acting as an acid? This is an acid, right? Because proton donor. So I can say that NH4 plus is your acid, correct? And donating a proton turns into NH3 plus a H plus. Okay, that is your buffer equation now, guys. Please write it down. Thank you very much. And guys, let's fill it up. Give me a second. I go washroom real quick. Come. Okay, let's say, right, when a base is added, so OH minus is added, right? So again, if you add OH minus, we'll always combine with a H plus, right? So the concentration of H plus, yes, salt always dissociate fully. You are right. Salt always dissociate fully. So OH minus will combine with a H plus, turn into a H2O, right? So additional OH minus are removed by H plus. So you see, right, your concentration of H plus decreases, direction of equilibrium shift to the right. Okay, and position of equilibrium shift to the right. And your concentration of H plus, right, returns original. Understand? All right, guys, next, when acid is added, then how? So concentration of H plus increases, right? Okay, as additional H plus will combine with OH minus to form H2O. Okay, now. Okay, you see, right, guys, if I increase the concentration of H plus will, okay, wait a minute. Nope. So I can mention that H plus will not combine with OH minus. I want you guys to change this equation to NH3 and forming NH4 plus. Correct. So again, if you increase the concentration of H plus, direction of equilibrium shift to the left, and position of equilibrium shift to the left. So at the same time, the concentration of how? So I can say that, right, you have a large reserve of NH3 and NH4 plus, right? So the concentration of NH4 plus increases. Okay, as H plus ion reacts with NH3 to form NH4 plus, so the pH stays the same. And guys, please write it down. Give me a minute. All right, guys, now let's move on to the next part. Come, come. All right, now, how do you calculate the pH of a weak acid, right? What do we need? First, we need either a Ka or the pKa of the weak acid. Okay, second, right, we need the equilibrium concentration of your weak acid and its salt from rice table. Highlight the word concentration of weak acid and its salt from rice table. This is the most important one, yeah, guys. Okay, next. For example, right, the pH of a buffer solution consisting this amount of propanoic acid and this amount of sodium propanoate. Okay, and your Ka is also given. So guys, I'll give you the step, yeah. All right, now let's continue. First, what I want you guys to do, right, is to construct Ka equation. No, sorry. Before your Ka equation, I need buffer solution. Buffer equation, go. So guys, how's my buffer equation? Again, yeah, buffer equation, right? It's always the same as a weak acid dissociation equation. C2H5COOH turns into C2H5COO minus and a H plus. Okay, that's your first step, yeah? So guys, after your buffer equation, right? Second, I want you guys to construct Ka equation, go. Okay, what's my Ka equation, guys? It's gonna be Ka equals to the concentration of a H plus, the concentration of your salt over the concentration of your acid, right? Done. And third step, right, kid, this is the hardest part, is to use a rice table to find your concentration of acid and a salt. Okay, so rice table to find a concentration of acid and also the salt. Okay, so guys, for this question, right, the concentration is already given. You see, the concentration is given to you already. So if concentration is given, right, then you don't need to use Rice table. But most of the time, in exam, right, the concentration is never given. Later we'll have some questions here, then we can try it out. Okay, so for this question, right, since concentration is given, there's no need for Rice table. So I can straight away write it as H plus. Okay, you can just rewrite this equation, right? Move this over, then move this over. Can I say that H plus is equals to Ka multiplied by C2H5COOH over a C2H5COO minus. And what is my concentration of Ka? We have found it already. Sorry, what is my Ka value? 1.35 times 10 to the power of -5, correct. Then multiplied by C2H5COOH is 0.6 over 0.8, right? All right. So usually, this two concentration, right, is from Rice table. If it's not given. And guys, finally, calculate pH. What's the value here? 5.99. Is that right? Done. Okay, guys, please try your answer. Once done, let's move on to next part. Yeah. 4.99. Wait, what did I do? It is stand for -5, right, bro? Yeah. Sorry. Careless calculation. Huh? At least I go down. Oh, good. All right, guys, please share your answer. Once done, I'm moving on to next part. Yeah. All right, guys. Now, to make your calculation easier, right? Okay, we have two different formulas that you can apply. So to make your calculation easier, I can say that pH, right, is equals to negative log base 10 Ka multiplied by your concentration of your acid over the concentration of the salt. Done. And guys, let's say if you're applying this equation, right, remember this is only for buffer solution only. Okay, it's only and only for buffer solution. Okay, next, we can also use, let's say, right, a pKa is given 10. So to find your pKa, right, I can also use this equation, pKa, okay, of your buffer solution, right, it's equals to, sorry, what pK? pH of the solution, right? Let's say a pKa is given, I can write it as pKa minus a log base 10 concentration of acid over salt. Done. Okay, please write it down, guys. Okay, highlight this word. Guys, if concentration of salt is not given, perform rise table. Okay, I'll show you one example of a question that requires rise table. Guys, I'm gonna go through it very, very slowly. Despite just being a 3-mark question, right? It's quite difficult. It's quite difficult. So haven't done it. Okay, okay. All right, guys, now the numerical value of Ka of your NH4 plus is given to you. And a buffer solution was prepared by using this ding, okay, 0.8 dm cube of this amount and access to this amount of HCl. Okay. So guys, again, first step, it's always to construct your buffer equation first. Again, if you're stuck, right, anyhow, just construct your buffer equation. So guys, I know that, right, my buffer equation is what? NH4 plus. Remember, okay, it's always a weak acid dissociation equation. So NH4 plus turns into NH3 plus H plus, right? Am I right? Oh, please, everyone. All right, guys, second step. I'll find your Ka equation. So your Ka equation, right, is gonna be NH3, H plus, NH4 plus. Correct. So I need to find H plus, right? Rearrange it. It's gonna be what? Ka times acid over the salt, right? Am I right? All right, guys, now, you see, right? We have the concentration of ammonia, but this is not at equilibrium. We have the concentration of NH4 plus or not? No. We don't have the concentration of NH4 plus. Read the question. There's no concentration of NH4 plus. So which is why the hard part comes here. Okay, this is the hard part now. So again, now you just have to find the concentration of NH3 and also your NH4 plus. Yeah. So guys, again, if you have no idea how to do it, rise table. So I know that what am I adding? I'm adding ammonia into HCl, right? Write down the equation first. Ammonia plus HCl turns into NH4Cl or NH4 plus Cl minus. Okay. Okay, now guys, rise table now. Go. I'll let you guys go after finishing this here. Do your rise table now. Ratio, initial mole, change, and that is so AS, right? Go do it now. So guys, you see, right? What's the ratio? 1, 1, 1. What is your initial mole, guys? Your initial mole is this amount, right? 0.8 and 0.25, right? How much is it? Yeah, 0.2. All right. And guys, what about the mole of HCl? 0.2 dm cube, 0.2. And initially, I do not have any NH4Cl. Understand? And guys, what about the change? So change, we always minus off the limiting, which is 0.04. This I minus 0.04. This I plus 0.04. So at the end of the day, there's no HCl left. I will have 0.04 mole of NH4 plus, 0.16 mole of NH3. Understand? And guys, you can just do one more by identifying the concentration here. So what's the concentration? What is the total volume, guys? Please tell me, what's the total volume now? You see, right, guys, the total volume is 0.2 plus 0.8 is just 1 dm cube, right? So one more time, 0.8 dm cube, 0.2 dm cube, total volume is 1 dm cube. So how do you find the concentration? It's gonna be 0.16 mole divided by 1 dm cube, right? 0.16 mole per dm cube, they are the same, right? This one the same, right? 0.04 mole divided by 1 dm cube, 0.04. Am I right? Okay, and last step. Negative log base 10 H plus, the entire thingy go over, right? Which is gonna be negative log base 10. Ka is given 5.6 times 10 to the power negative 6. And H4 plus is given 0.16, 0.04, and NH3 is given 0.16, right? Plug it in, guys. What's your answer? Okay, so your answer is about 9.85. Done. Here are peeps. Understand doable, guys? How is it? Okay, so this is one of the question, right, whereby the concentration of the conjugate is not given to you. So you have to find your conjugate concentration by using a Rice table. Okay, so please write it down. We'll stop the lesson here. We have a lot of practices here. Next, the next class we're gonna have, right? Okay, we will finish the entire Ionic Equilibria. Okay, we just need one more lesson to finish up Ionic Equilibria. Okay, and guys, gentle reminder, there's no class tomorrow. I'll see you guys week after. I'll see you guys after CNY. Yeah, all good. And bye bye. See ya.
Please like and subscribe.
Please like and subscribe.